Hi everyone. In this video, I am going to discuss about transfer function of block diagram representation of a system into signal flow graph. And this is the previous examination question, JNTUA previous examination question in the year April 2021. Convert the block diagram representation of a system shown in figure into a signal flow graph. Hence, find the transfer function C of S by R of S of the closed loop system from the signal flow graph. And this is the given block diagram. So find out the transfer function of closed loop system. So first convert this block diagram into signal flow graph. How to convert the block diagram representation of a system into signal flow graph of a system? The nodes The nodes are assigned at input, output at any summing point and branch point. Now here in this block diagram representation, R of S is an input, C of S is an output, and this is the summing point, and this is the branch point. Okay, the input signals, output signals, summing points, and branch points are considered as a nodes. Input signal R of S and C of S are the input and output signals, and summing points and branch points are considered as a nodes. So now here, and this is the node, so this is the branch point and this is the branch point. So these two branch points are considered as a single branch point. So combining the branch point and splitting the branch points. So these two branch points are considered as a single branch point. Here also this is the branch point and this is the branch point. So these two branch points are considered as a single branch point. So first indicates input signal, output signals, branch points and summing points are considered as a nodes. And this is the input signal. This is the input signal. This is the node 1. And this is the summing point, second node. And this is the summing point, third node. And this is the summing point, fourth node. And now here these two branch points are considered as a single branch point, and this is the branch point. So this branch point is considered as a fifth node, and this is the summing point. This summing point is a sixth node. Now here these two branch points, combining the branch points, these two branch points are considered as a single branch point, and this is seventh node, and this is the output signal, and this is eighth node. First represent input signal, output signal, summing points and branch points are considered as a nodes. So now here totally how many nodes? Totally there are 8 nodes. First node, second node, third node, fourth node, fifth node, sixth node, seventh node, and eighth node. And this is input R of S, and this is output C of S. So from this block diagram representation, from node 1 to node 2, and this is the system block. This system block is represented as a branch gain. This system block is represented as a branch gain. From node 1 to node 2, the branch gain is 1. Node 1 to node 2, the branch gain is 1. Node 2 to node 3, the branch gain is 1. Node 3 to node 4, the branch gain is the system block. That system block is represented as a branch gain. Now here the gain of the branch is G1, And block 4 to block 5, node 4 to node 5, the gain is G2. Node 5 to node 6, node 5 to node 6, the branch gain is G3. Node 6 to node 7, node 6 to node 7, the branch gain is 1. And 7 to 8, the branch gain is 1. And after that, the feedback loops from node 5 to node 6. And this is the loop node 5 to node 6, node 5 to node 6. The gain is G4. And node 7 to node 4, node 7 to node 4, node 7 to node 4, the feedback loop is H2 along the direction of the signal flow. Node 5 to node 3, the feedback element is H1. Along the direction of the signal flow. Node 7 to node 2, node 7 to node 2, the feedback element is 1 along the direction of the signal flow. And this is the signal flow graph from the given block diagram representation. So using signal flow graph procedure, find out the transfer function of the system. Step 1. Find out the forward paths. Find the forward paths and forward path gains. So forward path is a path from input node to output node that does not cross any node more than once. So now here the forward path is first forward path is 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. So that is the first forward path. Forward path 1 is 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. And this is the first forward path. And this gain is 1, this branch gain is 1, and this branch gain is G1, this branch gain is G2, this branch gain is G3, this branch gain is 1, this branch gain is 1. And that is the first forward path. And second forward path 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. So forward path is a path from input node to output node that does not cross any node more than once. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 5 to 6, 6 to 7, 7 to 8. Node 1 to node 8. And this gain is G4. This gain is G2. This is 1. This is 1. This branch gain is 1. This branch gain is 1. This branch gain is 1. So these are the forward paths. The total number of forward paths are 2. Number of forward paths 2. Now next calculate the forward path gains. The forward path gain is the product of the branch transmittance. Product of the branch transmittance. And this forward path gain is considered as P1 and this forward path gain is considered as P2. And what is the definition of forward path gain? Forward path gain is the product of the branch transmittance 1 into G1 into G2 into G3 into 1 into 1. The first forward path gain is P1 is G1 into G2 into G3. And the second forward path product of the branch transmittance. So that is 1 into G2 into G4 into 1 into 1. G2 G4. And this is the second forward path gain. So that is step 1. Next, second step, calculate the individual loops. Step 2, to determine individual loops and individual loop gains. Individual loops and individual loop. First individual loop. 3 to 5, 5 to 3. And here the gain is G1, G2, H1. G1, G2, H1. And that is the one individual loop. And second individual loop, 4 to 7. 4 to 7, 7 to 4. Four to 5, the gain is branch gain is G2. 5 to 6, the branch gain is G3. And 6 to 7 to 4, the branch gain is feedback gain is H2. G2, G3, this branch gain is 1 and this is H2 and it is second individual loop. So now here the feedback element is here negative sign is there. So this is minus H1 and minus H2. Now here the negative feedback element is there minus H1 minus H2. Next, third individual loop is 2 to 3, 2 to 7, 7 to 2. Third individual loop 2 to 7, 2, 3, 4, 5, 6, 7, 2 to 7, 7 to 2. Third individual loop. And this gain element is minus 1. Now here the negative feedback is there. So negative feedback, unity negative feedback. So that is minus 1. And 3 to 4, 1, G1, G2, G3, 1 gains, branch gains. This branch gain is 1. This branch gain is G1. This branch gain is G2. This branch gain is G3. This branch gain is 1. And this is third individual loop. And fourth individual loop is fourth individual loop, 4 to 5, 5 to 6, 6 to 7, 7 to 4, fourth individual loop, 4 to 5, 5 to 6, 6 to 7, 7 to 4. And this gain is, and 4 to 5, the gain is G2, and this gain is G4, and 6 to 7, this gain is 1, and 7 to 4, this gain is minus H2. Next, fifth individual loop is 2 to 5, 5 to 6, 6 to 7, 7 to 2, 2 to 5, 2, 3, 4, 5, 5 to 6, 6 to 7, and 7 to 2. And this is unity negative feedback minus 1. And 2 to 3, the gain is 1. 3 to 4, the gain is G1. 4 to 5, the gain is G2. And 5 to 6, the gain is G4. This gain is 1. And these are the individual loop from the signal flow graph. And now calculate the individual loop gains. So individual loop gain is the product of the branch transmittance. Individual loop gain is the product of the branch transmittance. And this is the first individual loop. So this individual loop gain is product of the branch transmittance G1 into G2 into minus H1. This loop gain is minus G1, G2, H1, and this is loop gain 1, first loop gain, and this is the second individual loop, and this second individual loop gain is product of the branch transmittance G2 into G3 into 1 into minus H2. L2 is equal minus G2, G3, H2, and this is the third individual loop. This third individual loop gain is L3 is equal product of the branch transmittance 1 into G1 into G2 into G3 into 1 into minus 1. So minus G1, G2, G3, and this is the fourth individual loop. So this fourth individual loop gain is L4, which is equal to product of the branch transmittance, that is G2 into G4 into 1 into minus H2 minus G2, G4, H2, and this is the fifth individual loop, that is L5. Individual loop gain is L5, so which is equal to product of the branch transmittance, that is 1 into G1 into G2 into G4 into 1 into minus 1. So minus G1, G2, G4. And this is the second step. Determine the individual loops and individual loop gains. And next step 3 is gain products of two non-touching loops. Step 3. So to find gain product of two non-touching loops. Gain product of two non-touching loops. So now here in this signal flow graph, there is no possibility combinations of two non-touching loops. There is no possible combination of two non-touching loops, and there is no possible combination of three non-touching loops. There are no possible combinations of no possible combinations of two non-touching loops. And similarly, to determine gain product of three non-touching loops in this signal flow graph, there is no possible combination of three non-touching loops, and there is no possible combination of four non-touching loops. Next, step number 4, find out the step number 4, determine or to find delta and delta k. So first calculate the delta. The equation of the delta is equal 1 minus sum of individual loop gains plus sum of gain products of all possible combinations of two non-touching loops. Delta is equal sum of individual loop gains plus gain products of all possible combinations of two non-touching loops minus gain products of all possible combinations of three non-touching loops plus and so on. So this is the equation of the delta. So now here 1 minus sum of individual loop gains. And what are the individual loop? Totally there are 5 individual loops, and sum of individual loop gains L1 plus L2 plus L3 plus L4 plus L5 plus gain products of two non-touching loops. There is no possibility combinations of two non-touching loops, and there is no possibility of possible combinations of three non-touching loops. So therefore, substitute L1, L2, L3, L4 and L5 values, and again L1 is minus G1, G2, H1, and L2 is plus into minus minus G2, G3, H2 minus G1, G2, H1 minus G2, G3, H2 minus G1, G2, G3 plus into minus 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 G1, G2, G3, and L4 is minus G2, G4, H2 minus G2, G4, H2, and L5 is minus G1, G2, G4. So now where the plus is there, plus into minus minus. So for all these terms, negative sign is common. Before minus is there, minus into minus plus 1 plus G1, G2, H1 plus G2, G3, H2 plus G1, G2, G3 plus G2, G4, H2 plus G1, G2, G4. So this is the value of the delta. Next calculate delta k. Delta k is equal to delta. Delta k is equal to delta for that part of the graph which is not touching kth forward path. Delta k is equal to delta for that part of the graph which is not touching kth forward path. Now here the total number of forward paths are 2, and first forward path k is equal to 1. For first forward path k is equal to 1, delta 1 is equal to delta. What is the first forward path? And this is the first forward path. and this is the first forward path. Delta 1 is equal to delta. So what is the expression of the delta? Delta is equal to 1 minus sum of individual loop gains. Sum of individual loop gains plus gain products of all possible combinations of two non-touching loops. Okay, so in this first forward path, and this is the first forward path and this is the second forward path, and now here delta 1 is equal to delta which is equal to 1 minus since there is no part of the graph which is not touching first forward path. So since there is no part of the graph which is not touching first forward path, and sum of the individual loop gains 0. So 1 minus 0 is equal to 1. Delta 1 is equal to 1. And the second forward path. For the second forward path, k is equal to 2. So delta 2 is equal to delta k is equal to delta. Delta 2 is equal to delta. Delta is equal to 1 minus here also there is no part of the graph which is not touching second forward path. So that individual loop gain product is sum of individual loop gain is 0. So therefore delta 2 is equal to 1. Delta 1 is equal to 1 and delta 2 is equal to 1. And now finally calculate the transfer function of the system. Step number 5. Find out the overall transfer function of the system. Step number 5. To determine overall gain of the system. Overall gain or overall transfer function of the system. So we know that using Mason's gain formula, the transfer function T or T of S is equal output by input. C of S by R of S is equal to 1 by delta sigma k is equal to now here the total number of forward paths are 2. K is equal to 1 to 2 into P suffix k into delta k. So that is equal 1 by delta into substitute k is equal to 1 P1 into delta 1 plus substitute k is equal to 2 P2 into delta 2. So which is equal to, and P1 is G1, G2, G3 into delta 1. Delta 1 is 1 plus second forward path gain P2 is second forward path gain P2 is G2, G4. G2, G4 into delta 2 is 1. So divided by delta. So what is the delta? And this is the delta value. Delta is 1 plus G1, G2, H1 plus G2, G3, H2 plus G1, G2, G3 plus G2, G3, G2, G4, H2 plus G1, G2, G4. So this is the overall transfer function of the given block diagram. That given block diagram is converted into signal flow graph. So using signal flow graph procedure, so this is the transfer function of the given system.